Alright, screencast number 2 entitled The Law of Diminishing Marginal Returns. Today we're going to come across one of the most important laws in all of microeconomics, the law of diminishing marginal returns. And we're going to come across it in the context of the same example we were using last time, Tina's Pillow Pet Factory. So to remind you what that looked like, we were working in this table where we calculated marginal product and average product for various quantities of workers and how much they produced. Now, if you look closely at that marginal product column, and maybe you were wondering about this originally, you'll notice some things. First, notice that that second worker adds more to production than the first worker did, and the third worker added even more to production than the second worker. Now that makes sense. Two people can often make more than two individuals can make individually, right? That's called specialization. Say we're talking about a pizza place, right? If one person has to do everything, make the dough, make the sauce, make the cheese, they might not produce as much, or two of them individually wouldn't produce as much as two people working together, right? One person focusing on the cheese and the sauce, one person focusing on the dough. So you can see that in the table in terms of the marginal product column. The first worker added 5 to production, the second worker added 10, and the third worker added 15. We were getting more and more, or bigger and bigger jumps in production as we were hiring workers, at least initially. But also notice what happens to marginal product with workers 4 through 7. You'll notice, importantly, that marginal product starts to drop. In other words, each worker, once we start with worker number 4, is adding less to production than the worker that came before. That has a name. It is called the law of diminishing marginal returns. Again, you can see that in the table. Look at the marginal product column and notice that after worker number 3, or starting with worker number 4, that marginal product number starts to drop to 10, 5, and then it actually goes negative, -5, -10. Now you might wonder why that is. And often students will think, well, these are just bad workers, or maybe they're lazy workers. But that's not actually what's going on. This is an unavoidable law. That's why it's called the law. It's an unavoidable consequence of production, at least in the short run. And I should mention that the law of diminishing marginal returns is exclusively a short-run concept. And you'll remember what the short run means. It means that a business is operating where something is fixed in their production. There's something that they cannot change. So here's the official definition of the law of diminishing marginal returns. As a business continues to add a variable resource, a resource they can change, typically we talk about workers, to a fixed resource, like a certain factory size or a certain amount of machinery or a certain number of machines, the marginal product of the variable resource, like workers, will eventually start to drop. That's the law of diminishing marginal returns. Now be careful here because it sounds a lot like the law of diminishing marginal utility, and the concepts are very similar, but they're not exactly the same. The law of diminishing marginal utility was about how when you consume something, it becomes less and less enjoyable. The law of diminishing marginal returns is about the production or the productive capacity of a variable resource. It's kind of like the law of diminishing marginal utility, but applied to workers. Workers get less and less effective. Now, why is that? Well, as the variable resource like workers is added, what's going to happen if there's something fixed in the business, like a certain amount of space or a certain number of machines, is that those workers are going to start to experience crowding, miscommunication, they're going to start waiting in line to use the fixed resources like those machines, and etc. And if we haven't done so already, we'll do an activity in class where I'll try to demonstrate this. So if you doubt this, imagine that you've just opened a pizza shop, maybe the size of my classroom. If you hire one worker, you'll start making pizza. If you hire 2 workers, you'll probably make more pizza. But imagine you've just hired 2,000 workers, and you're wondering how productive that 2,000th worker is going to be. Well, you say you can't fit 2,000 workers into my classroom. That's fine. I get a bulldozer, and I bulldoze 2,000 people into the door of my classroom. They're piled in a big bloody mess from floor to ceiling. How many pizzas are they going to make? Exactly. Law of diminishing marginal returns. At some point, you have so many workers, so much of a variable resource, there isn't any more room. They can't possibly use the machines because they're all a big bloody mess. That's the law of diminishing marginal returns. So if you see a table of marginal product, what you're looking for is that worker or that unit of a variable resource where marginal product starts to drop. That's where the law of diminishing marginal returns sets in. So looking back at our little table, notice you have the number of workers, and what you're looking for is the marginal product column, and specifically as soon as marginal product begins to fall. If you look carefully enough, you'll notice it's happening right there. After the third worker, or starting with the fourth worker, we start to see that fall in marginal product. That's where diminishing marginal return sets in. So I would say that in this example, that diminishing marginal return sets in either after the third worker or beginning with the fourth worker. Either way is an acceptable way to say it. Alright, so now we're going to take some of that data and we're going to graph it out. And specifically, we're going to graph out total product, marginal product, and average product and start looking for these concepts in the graph. So let's start with total product. Now notice as you look down that total product column, total product initially increases, it hits some maximum, and then it starts to decrease. So if you look at the top graph, I've graphed out what that would look like. I have quantity of labor on the x-axis, different numbers of workers, and then total product on the y-axis. And again, you can see what's going on. Total product initially increases, it hits some maximum, and then it starts to decrease. Next, let's look at the marginal product column. And again, as you look at those numbers, you'll see something pretty similar. Marginal product begins to increase, hits a maximum, and then starts to decline. So when I graph that one out, and I'll do that in the bottom graph, again, quantity of labor on the x-axis, average product and marginal product on the y-axis, again, we see kind of the same thing. Marginal product rising initially, hitting a peak, and then beginning to fall, eventually going negative. Finally, the average product column looks very similar. Average product rises, peaks, and then begins to fall. When I graph that out, here's what it looks like, the orange line. Average product rising initially, peaking, and then falling. Alright, now let's incorporate that idea of the law of diminishing marginal returns. First, focus on the area of marginal product where it's rising. Where marginal product is rising, total product is increasing, and it's increasing at an increasing rate. Each worker is adding more than the worker that came before, at least initially. They're specializing. We call that increasing marginal returns. That area where marginal product is rising and total product is rising at an increasing rate. For you calculus people, you can make a relationship between marginal product and average product. I'm not going to use the D word, but there it is. Now, as soon as marginal product begins to fall, here, now we're in the area of diminishing marginal returns. Graphically, what you're looking for is the same thing you were looking for in the table. As soon as marginal product starts to drop. Now, where marginal product's dropping, total product is still going up. The reason for that is that these marginal product numbers are still positive numbers. The workers are still adding something to the production process. They're just adding less and less and less than the workers that came before. So where marginal product is dropping but still positive, total product is rising, but now it's rising at a decreasing rate. It's not rising quite so quickly. Notice that where marginal product is 0, that's where total product tops out. This worker is adding nothing to production. So total product doesn't go up anymore, but still it doesn't go down. Finally, you'll notice in the table that there are some workers for which the marginal product is negative. We call those negative marginal returns. And when marginal product is negative, total product begins to drop. Marginal product, average product, and total product graphs will always have these shapes because no business can escape the law of diminishing marginal returns. Now, one more thing I want to point out in this graph that I'll come back to. Look closely at the marginal product and the average product curves, and specifically look at where they're crossing, right here. You'll notice that right there, average product is at its absolute maximum. Where marginal product and average product cross, average product is peaking out. Now there's a reason for that, and we'll come back to that reason in a future screencast.
Oh no! Oh no! Oh no!
Oh yeah!